Hey everyone, today's guest is Dr. Linda May Zhang, who recently published a paper entitled Ergothioneine for Cognitive Health, Longevity, and Healthy Aging. Where are we now? Today, Dr. Zhang will present data from that paper, followed by Q&A. So welcome, Linda, and let's get into the presentation.
Thanks, Mike, for the kind introduction. I am very, very excited and honored to be on your channel today to talk about this really interesting compound, ergothioneine. So, Mike, we previously didn't know each other. I watched some of your YouTube videos, and I really appreciate the way you communicate science to your audience. The rigor, the depth, I completely appreciate it, and I'm happy that you want to showcase ergothioneine. So today we're going to talk about ergothioneine. It's often shortened as Ergo or EGT and why it's getting attention in the healthy aging space. This is just a quick note before I begin. This presentation was created for educational purposes only. It's intended to provide valuable information on the science and applications of ergothioneine. We at Blue California, we're not making any claims that explicitly or implicitly indicate that ergothioneine can diagnose, cure, treat, or prevent any disease. So nothing on here should be taken as personal medical advice. If you have health concern or questions, please talk to your local healthcare professional. Okay, so before we get into ergothioneine, let's take a step back and ask, why is healthy aging such an urgent topic? On average, people are living longer than ever before thanks to modern medicine and healthcare. By 2050, one of every six people is projected to be over 65 years old, and we're seeing a boom in the population of people who are over 80 and above. So we're expecting a population of over 450 million people to reach 80 and above by 2050. So now we're making great strides in terms of lifespan. The question now really are we as a population healthy as we age, especially in those later stages of life? The answer might not be too optimistic, especially in the United States. Right now in the United States, 6 of every 10 people are living with at least one chronic disease. And this includes heart disease, stroke, cancer, type 2 diabetes, chronic lung disease, obesity, Alzheimer's, and so forth. And what's more incredible is that one of every four out of every 10 adults live with at least two or more of these chronic diseases. So the question really isn't about, can we live longer anymore? It's about maximizing what's called health span. So health span is defined as the period of one's life spent living healthy and free from burdens of disease. At Blue California, we like to approach health span from a nutritional point of view, and we believe Americans may not be getting this important nutrient in their diet called ergothioneine. So ergothioneine, that's what we're going to be talking about today. It is, it's a once niche nutrient. To be honest, it's still probably a niche nutrient, but nowadays it's a fast-growing research topic. This slide shows the publishing trend of ergothioneine, basically how many scientific studies have been published over time, at least in the biomedical sciences. You could see on this timeline that the field is generally quiet until 2004 and 2005. And then there was a steady and growing output of research studies that really exploded in the past 5 to 7 years. And so now we're looking at about 80 to 100 papers that are now published per year. So what's interesting is that ergothioneine as a compound itself was actually discovered over 100 years ago, so way before 2005. But research really started around 2005 because that was the year of the discovery of an ergothioneine transporter that could draw ergothioneine inside cells. And this transporter was found in animals and humans. We're going to talk about this a little bit more later. But the question is, okay, if the body has a transporter for something pretty specific for ergothioneine and allows this nutrient to get inside cells, then it must be important. How is ergothioneine important? What is its biological function? And so that's when the research really picked up, and now it's accelerating. Here are some screenshots of some of the papers that have been published in this past year. You could see examples across various topics related to healthy aging, from cognitive health to age-related hearing loss to cardiovascular disease, intestinal health, skin protection, longevity, at least longevity in animal models, telomere support, physical performance, and health span. So these papers span a pretty broad range of topics. And in totality, it suggests that ergothioneine might be a foundational nutrient, something very important and basic to support healthy aging. All right, so let's talk about ergothioneine. What is ergothioneine? Where does it come from? I always like to start with the name, ergothioneine. Ergo comes from the fact that this compound was originally identified from the ergot fungus, and that infested wheat crops, rye crops back in the early 1900s. So ergothioneine was identified from the ergot fungus back in 1909. It's really interesting because back then people ingested these infected crops on accident and they got ergot poisoning. But ironically, like a lot of things in science, ergothioneine was identified to be ironically good for the body. So it's kind of funny how that is. Ergothioneine is synthesized mainly by fungi, some bacteria, some yeasts, and can be only found in the diet, mainly mushrooms as the primary source. It's not synthesized by the mammalian body, including humans. So the body doesn't make it. It's synthesized by fungi, bacteria, and how we get it in, get it in we have to ingest it through our diet. So going back to the name, ergothioneine, thione. Ergothioneine is a thione at physiological pH, which can tautomerize into a thiol. You've probably already heard of thiol antioxidants. One of the most abundant thiol antioxidants is glutathione in your body. A thione is characterized by a carbon-sulfur double bond. And you can see on the ring structure here, there is a double bond here, versus a thiol is characterized by a carbon-sulfur single bond. So this is a bit nuanced, a little deep, but why does it matter to know this or to us? Well, at physiological pH or even acidic conditions, which is found in the human body, thiones, which is what ergothioneine is at physiological pH, are much more stable than thiols. So that is one reason why ergothioneine is a very stable antioxidant molecule. So going back to the name ergothioneine, the "-nine" part just lets us know that this is an amino acid. You can see from its chemical structure that ergothioneine is very, very similar to the amino acid histidine. So sometimes it's referred to as a histidine derivative. Lastly, at least, on this slide, ergothioneine is also very water soluble and has demonstrated to have high bioavailability. It's demonstrated to absorb well in the bloodstream. Once in the bloodstream, it's not rapidly cleared. So later on, I'm going to show you data to demonstrate this. But right now, I'm just illustrating some unique features of ergothioneine that stand out. Let's dive deeper now into the dietary source of ergothioneine. This table shows ergothioneine content across foods, including different types of mushrooms, like the king bullet, jewel ears, oyster mushrooms, portobello mushrooms, button mushrooms. This table is just one data set, and there's many other studies that have measured high amounts of ergothioneine in other mushrooms, such as porcini mushrooms, shiitake, lion's mane, including some other mushrooms. Mushrooms are the richest dietary source by far because ergothioneine is made by fungi, as I mentioned, and mushrooms, being the fruiting bodies of fungi, can therefore synthesize it. But if you can see the rest of the table, you may notice that ergothioneine can be found in other dietary sources too, including grains, seeds, nuts, beans, vegetables like broccoli, onion, spinach. How do these plant sources contain ergothioneine? Well, ergothioneine, it's made by fungi, bacteria. It's thought that ergothioneine made by the fungi and bacteria in the soil is taken up by these plants. So there is a professor, he's retired now, Professor Bob Bielman from Penn State University. He's very passionate about this research area, and he often talks about how soil tillage reduces ergothioneine in crops because tilling disrupts the fungal networks in soil. So he's always talking about, hey, it's important to maintain or think about at least soil health. Therefore, that will improve the health or the nutritional content of agriculture and therefore human health. Lastly, at the end of this table, we could also see that animal products like chicken, pork, beef, and eggs also contain ergothioneine. You know, small amounts of ergothioneine, but they do contain ergothioneine. Where do animal products get the ergothioneine? Well, they get it from their feed, and ergothioneine is retained in the body. So I mentioned in an earlier slide that really it's the discovery of the ergothioneine transporter is what drove the scientific interest in terms of understanding what ergothioneine is doing and its biological significance. Ergothioneine is not made in mammalian and human body, so it's really interesting that we have the cellular transporter that is fairly specific to ergothioneine. So I want to take a couple moments to talk about this ergothioneine transporter. So here is a diagram of a cell. I really, really like this diagram. It's the only, in-depth diagram I've seen in papers. The transporter is highlighted in the yellow circle. The ergothioneine transporter is also known as ETT or OCTN1, and you probably noticed this SLC22A4. That just stands for the gene that encodes the transporter. The existence of this transporter on cell membranes allows this nutrient to be taken up, get inside cells, and retained. Once inside cells, ergothioneine can do a number of things, including play a role as an antioxidant, as one of its functions. It could scavenge free radicals to prevent lipid oxidation, prevent protein oxidation, prevent even glutathione from being oxidized. Ergothioneine can also prevent DNA from being damaged. Ergothioneine is known as a metal ion chelator, so it could chelate metal ions like copper. It could activate endogenous antioxidant signaling pathways, so meaning ergothioneine can activate the cell's own antioxidant response system. The transporter is also found on mitochondrial membranes too, which is really interesting. So ergothioneine can get inside mitochondria to scavenge the excessive free radicals that can cause mitochondrial damage. This is important. We're talking about a lot nowadays about maintaining mitochondrial health. The mitochondria is the powerhouse of your cells, and it's important to produce energy for nearly all your body processes. So it's very important to take care of your mitochondrial health, especially when it comes to healthy aging. So it's very, very interesting that ergothioneine can get inside cells and get inside mitochondria because of this unique transporter. This transporter, it's already interesting that we have this ergothioneine transporter. What's even more interesting, I mean, there's so many interesting things about ergothioneine. This transporter is expressed in so many different types of cells in the human body. We're not just talking about one cell type or one tissue type. It's almost expressed ubiquitously. So this graph just shows how many cell and tissue types the transporter is expressed in from, if you just read down the bone marrow, fallopian tube, small intestine, muscle, kidney, spleen, prostate, lung, different brain regions, heart, muscle, skin, so forth, on and on and on. I mean, you probably haven't even think about ergothioneine in terms of some of these cell types. It's so interesting that so many cells within the human body have evolved to express a transporter for a compound that the body doesn't even make. So this means, this is what signals researchers to say, oh my gosh, there's something very, very uniquely important about this dietary compound. The existence of this transporter, for example, the expression of this transporter in the small intestinal cells and enterocytes also helps with absorption and ability also to be retained in the human body. Okay, so now we've talked generally about what is ergothioneine, where does it come from, and we know that there is an existence of an ergothioneine transporter within our body. Now let's start taking a look at some human data, because that's what's really interesting. We will first start by asking the question, what happens to ergothioneine levels in the body as we age? Many nutrients decrease with age, including vitamin D, calcium, even natural molecules like glutathione and NAD. What about ergothioneine? So this is a study published in 2016 that examined plasma and blood ergothioneine levels in a senior population. On the left, the bar graph shows plasma ergothioneine levels plotted on the y-axis and age plotted on the x-axis. You can immediately see there is a downward trend of average plasma ergothioneine levels with increasing age. Levels start dropping, at least in this particular study, levels start dropping after the age of 65, but really drop after the age of 75. And that is similar to a lot of other molecules that drop with aging. In the same study, the researchers then examined a subset of subjects with MCI, or mild cognitive impairment, and they compared these subjects with age-matched healthy subjects. So they were healthy, they were not diagnosed with MCI, but they were matched in terms of age. So mild cognitive impairment, what is MCI? MCI is basically the stage of cognitive impairment between what you would expect in normal aging and dementia. So people, are characterized with having noticeable memory issues or thinking issues. They're forgetting things or having trouble finding articulation or the right words. And it's the stage where it's worse than typical age-related cognitive changes. And in fact, MCI can be a risk factor for developing dementia. So the researchers found that blood levels of ergothioneine were significantly lower than healthy age-matched controls. And you probably, if you're looking closely at this graph, you probably notice that this data is looking at whole blood. I didn't want to overload you with too many figures from this paper, but whole blood ergothioneine also decreases with age, and generally there is a linear relationship between plasma and whole blood. So the take-home message from this study is that with aging, blood levels of ergothioneine decrease, and is associated with one condition of aging, which is impaired cognition. Now, what about the relationship between life expectancy and ergothioneine? Since you could only get it from your diet. And we're talking about, ergothioneine in terms of healthy aging. So this particular analysis examines exactly this question. Life expectancy and estimated ergothioneine consumption was grouped by countries, including the US, Finland, France, Ireland, and Italy. Ergothioneine intake was estimated from the diet, which was taken from various national dietary surveys from the country's database, and that includes surveys that assesses mushroom consumption and other dietary sources like beans. So this graph shows a really interesting correlation that a diet low in ergothioneine is associated with lower life expectancy. And unfortunately, the US leads the charge in that. US being the country with the lowest ergothioneine intake and lowest life expectancy compared to other countries like Italy or Japan. And perhaps the consumption of mushrooms have something to do with it when mushrooms are more ingrained in the culture in terms of dietary habits. The researchers also looked at death rate from neurodegenerative diseases like Parkinson's and Alzheimer's. Low ergothioneine intake was also correlated with higher death rate from, Parkinson's, from neurodegenerative diseases. So you have Parkinson's on the left, Alzheimer's on the right. US and Finland having the highest death rate, and Italy and Japan having the lowest death rate, at least from the countries studied. Okay, so we just looked at data from a study linking dietary ergothioneine intake with life expectancy and mortality from neurodegenerative diseases. Now, zooming out, there are now at least a dozen human association studies looking at either plasma or blood ergothioneine and various diseases of aging or mortality. And they all suggest a consistent pattern. Higher blood or plasma levels of ergothioneine are linked to better health outcomes. So what you're looking here is a table that's derived from the review paper that you mentioned that was recently published this past year. I believe it's table 2. And this table summarizes all those studies. I know the viewers can't see the details of these studies, so I'm actually going to go through and highlight just a few examples. I think I'm going to highlight 3 or 4 examples of these studies in greater detail. Okay, so I'm actually going to go somewhat chronologically order on how they're placed on the table. So it's not one study is more important or bigger than the other. So we're going to look at the first study listed on the table. This study looked at the relationship between ergothioneine and psychological distress. The researchers measured serum ergothioneine in 444 individuals from the Hunter community study, and they examined psychological distress. They found that individuals reporting psychological distress had 24% lower serum ergothioneine levels compared to those without distress. And they also reported that each unit increase in serum ergothioneine levels was associated with 68% lower odds of having psychological distress. So those numbers are pretty profound. This suggests that ergothioneine may play a role in mood or mood management or psychological or physiological response to stress. So this is just one example. You're going to see after I talk about this, there's going to be a lot of correlations in which people with some kind of disease or disorder have lower ergothioneine levels compared to healthy. This next study from the table looked at the link between plasma metabolites and mortality risk. Researchers assessed roughly 5,000 participants from the Long Life Family Study, and they looked at hundreds of blood molecules, including ergothioneine. They found that one standard deviation increase in ergothioneine was associated with a 25% lower mortality risk. It's profound. This study also supports the earlier study that I mentioned that increasing dietary intake of ergothioneine is associated with a reduction of mortality. So it's very interesting. There is definitely a optimistic link between raising your dietary ergothioneine with longevity. Of course, any effects of a nutrient or intervention on longevity is very hard to assess in humans. It's really hard to say, okay, this actually causes greater longevity. You're going to have to run a study to track for an entire human lifespan. But I do want to, take a pause and show you a compelling lifespan study, at least done in an animal model. Usually researchers like to use laboratory rodents or fruit flies or C. elegans. They are shorter-lived models to test for lifespan. So in this study, researchers fed ergothioneine to mice through drinking water, starting about 7 weeks of age. So the mice were young, and they continued tracking these mice until the end of their life. You could see there's a survival curve here, and the control mice start dropping off around the 600 a day range. So that's about a year and a half. So the mice in mouse years, that's pretty old for a mouse. And in terms of the ergothioneine supplemented group, there is a rightward shift in survival, meaning there's more mice surviving longer and some living towards 800 to 1,000 days. It's a very large shift. So I will say this is an animal model. Of course, it doesn't prove that the same thing will happen in humans, but importantly, it adds biological support that ergothioneine does something in terms of longevity in a mammalian model. And interestingly, even though I'm not showing you the data, you can see it in the paper, the same lifespan extension effect has been reported in other models such as Drosophila and C. elegans. So in different models, this lifespan extension effect is replicated. So now let's go back to the table, the association tables that we were just looking at. The next association study relates to telomere length, which is related to lifespan. Telomere length is one of the 12 hallmarks of aging. Telomeres are basically the protective DNA end caps of chromosomes. They naturally shorten as cells divide, but shortening of the telomeres can be accelerated under oxidative stress, chronic inflammation, and with aging. So basically, shorter telomere length is found to be associated with higher risk of mortality and death from specific diseases. So this particular association study looked at the association of telomere length and serum metabolites in over 7,000 participants. In this particular cohort, they found that higher ergothioneine levels was positively associated with longer telomere length, which is very interesting. So you're starting to see a trend here among all these different, very independent studies looking at different cohorts. Of course, again, association isn't causation. I want to take a pause and highlight some very preliminary findings that potentially show that ergothioneine may causally influence telomere length. So these are studies that were actually conducted by Blue California. It's the company I work for, in collaboration with some other research groups. The very first left-hand side of the panel here is preclinical work. It's using cell-based models, and specifically, we looked at human fibroblast cells. And we asked a very simple question. Under oxidative stress conditions, does adding ergothioneine to the cell culture media help preserve telomere integrity? And what we found was yes. The addition of ergothioneine was able to increase telomere length, reduce the percentage of short telomeres, and also reduced the rate of telomere shortening when compared to untreated cells under oxidative stress conditions. So, of course, looking at a plate of human cells is not the same as looking at human beings. So we actually also recently looked at telomere length in humans as an exploratory endpoint. So on the right-hand side of the panel shows supplementary data from our own recent placebo-controlled double-blinded clinical trial. In this particular clinical trial, we looked at cognitive function, specifically memory as the primary endpoint in older, healthy adults. But we also looked at leukocyte telomere length as an exploratory measure because why not? We had the samples. I will talk more about this clinical study later in this presentation. So this study was a 16-week trial. It's only 4 months, so we were not expecting to see any measurable difference. But we did see a significant change compared to baseline in telomere length in one of our treatment groups, which is the 10 milligrams of ergothioneine per day. I will note that the overall model effect was not statistically significant, so we will just treat this as a preliminary signal. But it's very, very interesting that we do see a change from baseline, especially in light of our in vitro assay and the recent association study. So the potential effect on telomere length is certainly interesting and worth exploring in future trials. Now I'm going to go back to the table. I think I've highlighted maybe 4 association studies as an example. There's a dozen of them, but basically you could see the rest of these studies. Higher serum ergothioneine has also been reported as protective against erectile dysfunction. It's associated with better cognition. Lower ergothioneine levels have been seen in subjects with heart disease, also seen in subjects with cognitive decline and dementia. So again, the general consensus here is that higher blood or plasma ergothioneine levels are linked to better health outcomes. Conversely, lower blood or plasma ergothioneine levels is linked to worse health outcomes. With all these association studies looking at plasma ergothioneine levels, the next natural question is there a certain plasma level we should be targeting or a certain plasma cutoff that tends to separate, the better versus worse health status? There is a research group in Singapore that tried to explore that idea, and they compared plasma ergothioneine in 2 different groups. They looked at 544 individuals classified as healthy, meaning they do not have any diagnosis of disease. And they compared them with 354 individuals classified as unhealthy. And that's defined as at least having one chronic condition, including age-related macular degeneration, Parkinson's, mild cognitive impairment, Alzheimer's disease, and vascular dementia. On this scatter plot, you could see the distribution of plasma ergothioneine across groups. On average, the higher group, the healthy group tends to be higher, where the unhealthy group tends to be lower. Based on this data set, the authors proposed a theoretical threshold around 900 nanomolar of blood plasma ergothioneine levels. And this suggests that, okay, they suggest that below this level, the person may be more likely to fall in the unhealthy category. Now, it's important to emphasize that this is still association, not causation. But you could, and also you could see a substantial overlap in terms of the data points and could see substantial person-to-person variability. But the overall pattern supports the idea that, okay, plasma ergothioneine level may be a meaningful marker that differentiates between healthier and less healthier populations. The next practical question now is, can supplementation reliably move or change plasma ergothioneine levels upward? And if so, how much, how long does it last, and is there efficacy? Can supplementation improve any health outcomes? So these questions we're going to explore for the rest of this presentation. Here, I'm showing data from the first human study to look at absorption. And I'm showing just one graph here, but the researchers also looked at metabolism and excretion too. They found that, yes, supplementation raises blood plasma ergothioneine levels pretty well, and ergothioneine is actually retained in blood. So in this study, healthy young male volunteers were supplemented with either 5 milligrams per day or 25 milligrams per day of ergothioneine for 8 weeks. And then they stopped supplementation. The researchers then tracked blood ergothioneine levels during supplementation and also for weeks onward too, after they have completely stopped supplementation. And then they compared this to the placebo group. Starting with the 25 milligram dose that's shown in the dark gray bars, you could see that plasma ergothioneine levels rise pretty quickly, and it reaches a substantial increase in about a week, nearly tripling what's seen in baseline. At the 5 milligram dose that's shown in the light gray bars, this increase is a bit smaller, but still clear. Plasma levels rise around 60% compared to baseline. And what's really interesting is that when the subjects stopped supplementation, you could see that plasma levels remained elevated for an extended period of time, particularly in the high dose group, which gradually declines, but it still remains elevated above baseline even almost 4 weeks after supplementation. So this is the unique property of ergothioneine. It's a water-soluble amino acid, but even when you stop supplementing, you still have elevated levels in your blood. With the elevated plasma ergothioneine levels with supplementation, then what's the health outcomes? What do we see with supplementation? So this table, all these tables are from the review paper, so you could read a little bit more in depth with the paper. This table summarizes the published human interventional studies to date. Besides the earlier absorption metabolism trial that I showed you just a slide ago, there's currently, to my knowledge, just 4 interventional trials examining pure ergothioneine supplementation, not examining mushroom extracts, but pure ergothioneine supplementation that are peer-reviewed and published to date. I do know currently there are others that are finishing up or finished up or starting, but they're not published or at least peer-reviewed yet. So what you see on this table is generally 2 clinical studies looking at sleep and two clinical studies looking at cognitive function. In terms of the cognitive function, one clinical study is looking at healthy population, and one clinical study is looking at subjects with mild cognitive impairment. So next, I'm going to go through each of these trials in greater detail. I'm going to start with the cognitive trials first, and then I'm going to finish with the sleep trials. Okay, so first I'm going to start with a study that looked at cognitive function as well as memory and sleep in a population of healthy older adults. This is actually a study that Blue California supported and collaborated with researchers at the National Science Agency of Australia, which is called CSIRO. And recruitment also took place at CSIRO Australia, meaning the patient population are Australians. This study examined older subjects aged 55 to 79 years of age who are healthy, but they complained about having subjective memory loss. We had three study arms, placebo and two ergothioneine groups. One group received a dose of 10 milligrams per day, and another group received 25 milligrams a day dose, taken daily for 16 weeks. So approximately for 4 months. I'm first going to show you the plasma ergothioneine levels of these subjects after supplementation. Similar to what we saw in the previous study in the younger adults when they supplemented for 1 week, we see here that 10 milligrams and 25 milligram dose substantially increase plasma ergothioneine levels at the 4 week mark and even more substantially at the 16-week mark. So the key point here is that ergothioneine doesn't behave like other water-soluble compounds that peak out and then they wash out quickly. They have a very short half-life. We see a consistent pattern here that there is ongoing accumulation and sustained elevation in the plasma over weeks of time. Now, what happens? So, supplementation increases blood ergothioneine levels. What happens in these subjects? We found in this study that a higher dose of 25 milligrams a day of ergothioneine was able to improve composite memory. So it's an objective measure at 4 weeks based on standardized testing from the CNS VS battery of testing. Even though we can't explain this result, this change was no longer detectable at week 16. But we found a transient increase in the ability of our subjects in terms of measuring memory tests. We also analyzed subjective memory and subjective sleep quality. For subjective memory, we actually see that placebo group, shown in the gray bar, had worsened perspective memory over time, which was very interesting. With the ergothioneine group, there was a dose-dependent ability to improve memory with the 25 milligram group, seeming to fully improve this worsening effect that you could see compared to the placebo group. Now, I want to point out that subjective memory measures two different domains. One is perspective memory, and one is retrospective memory. So perspective memory is the ability to do something, remembering to do something in the future. Like I'm remembering to take my medication later, versus retrospective memory is recalling past information or events. Like I remember to take my medication yesterday. I remembered what I ate yesterday. So in our study, we see a difference in perspective memory, which is remembering to do something in the future. For subjective sleep quality, that's the graph on the bottom. I now have like three different graphs on here. We see something similar in terms of subjective sleep quality, a similar pattern as what we see in the subjective memory. We see a dose-dependent improvement in the subject's ability to get to sleep, with statistical significance in the higher group again, and that's the 25 milligram group. In this trial, we also assessed safety. I will say, even though I don't have the data here, there are no clinically relevant changes in blood biochemistry, which is what we want. We don't want any changes in blood parameters, and we saw no adverse effects with the ergothioneine supplementation at both groups. In fact, Ergothioneine supplementation seemed to improve liver function, especially at the higher dose of the 25 milligram group, which is interesting because you're probably thinking, oh my gosh, it's the substance is accumulating in the blood at such high doses. Is there any safety concern? And we're actually seeing that, okay, there's no safety concern, and it actually seems to improve the liver. At this dose, supplementation reduced plasma levels of plasma AST and ALT. They're both markers for measuring a liver injury. So, taken together in a trial of healthy older subjects, ergothioneine supplementation transiently improved composite memory objectively and improved subjective memory as well as subjective sleep quality as well as liver function. There was a second clinical trial that looked at cognitive function that took place around the same time as our study. I will note that both of our trials are completely independent of each other. This particular research group was from Singapore, and they studied a cohort of Singaporean Chinese. But both our research trials happened during COVID, which extended the timeline and just difficulties of managing a trial, and certain variabilities that we see in our research studies potentially can arise from the complications of the patients having to go into the clinic during the COVID era. So this particular study looked at a smaller pilot study of only 8 to 11 subjects split between two groups, 8 to 11 subjects per group, and they saw two groups, placebo versus the ergothioneine supplemented group. The subjects were older adults, ages 62 to 70 years of age, with mild cognitive impairment. So they were not considered healthy, but they're kind of in between stages of healthy and developing worsening cognitive decline. These subjects took ergothioneine at a dose of 25 milligrams, but not daily. They were given 25 milligrams 3 times a week for a year. So this is the longest interventional trial to date on ergothioneine. What the study found was that ergothioneine group displayed an improvement in learning ability on a standard memory test, shown as in the RAVLT domain at the end of the study. The blue line is the ergothioneine group, whereas the red line is the placebo group. There was statistical significance compared to baseline, shown on the graph, but also there is statistical significance compared to placebo group that's not quite illustrated on the graph, but in the text. It was also interesting to see that the placebo group, over the course of this 1 year study, showed an increase in plasma NFL. So that's on the right-hand side of the graph. NFL stands for neurofilament light chain, and that's a marker to indicate a neuron injury that is seen with neurodegeneration. So remarkably, the ergothioneine group, you could see the blue line is completely stable. It's able to fully prevent this increase of NFL in which the placebo group saw over this 1 year time course. So combining this study, which looked at a slightly unhealthy group, and our previous study, which looked at a healthy population, these two initial clinical trials really give encouraging support that increasing ergothioneine intake in your diet can improve cognitive functions. Now, the next two clinical trials I'm going to review focuses more on sleep. This particular study was published in 2022, so quite a number of years older than these two cognitive studies. And they studied generally healthy middle-aged adults, 51 to 55 years of age, who either reported higher anxiety or sleep complaints, but otherwise healthy, and they're not diagnosed with any type of sleep or anxiety disorders. There were two groups, 46 people per group, placebo or ergothioneine group, and they took 20 milligrams of ergothioneine for 4 weeks. Of the subjective measures they analyzed, they looked at sleep quality and they looked at anxiety. I will say, if you probably can't see this really well, but if you zoom in, there were almost all the measures had placebo effects. which is something you're like, no, you don't want this in a clinical trial, but it happens. All the measures had placebo effects, so both the placebo group and the ergothioneine group, they both saw improvements compared to baseline in terms of their subjective sleep score as well as the subjective anxiety score. But in terms of their, I boxed in just one parameter that did not show a placebo effect, and that's the sleeping difficulties. The placebo group did not improve, whereas the ergothioneine group did. So this study was a little bit hard to interpret. They published it, but it was suggestive that, hey, maybe ergothioneine can do something with sleep despite the placebo effects in this study. A newer trial was just published this past year, and they studied healthy adults aged 47 to 60 years of age. Subjects were given placebo and ergothioneine at a dose of only 8 milligrams daily for 16 weeks. And this study found that ergothioneine improved subjective sleep quality in terms of feelings of feeling refreshed after sleep, and sleep length. So this study is very interesting. It supported the previous study. It supported the subjective sleep that we saw in our study. The nuances are different in terms of the metrics analyzed and reported, and of course the dosing is a bit different. But now there are 3 clinical trials that suggest that ergothioneine may improve aspects of sleep, whether that's sleep difficulties, getting to sleep, feelings of refreshing, or sleep length. How exactly ergothioneine does this is not deeply understood yet, but it's certainly interesting. I will say ergothioneine is not known to cause fatigue. So usually in these clinical studies, patients usually take ergothioneine in the morning, and so not at nighttime. And they're not reporting, oh my gosh, I need to take an afternoon nap. There is somehow ergothioneine is doing something to the body or the brain to enable better sleep. And that's something that is just very interesting, and it would be very interesting to understand more deeply. Okay, so I'm going to switch gears just a little bit now and talk about safety. We just reviewed association studies, we've reviewed interventional studies. We're going to talk about safety. From a regulatory point of view, argathionine has been reviewed for use as an ingredient in both supplements and foods. In the US, it has GRAS status, which stands for generally recognized as safe, meaning experts have reviewed the safety dossier in which a company, including Blue California, has to submit. And they reviewed that, hey, this is generally recognized as safe in its intended uses in foods and supplements at a particular dose based on all the data to date. In Europe, EFSA stands for the European Food Safety Authority. That is their agency to also similarly evaluate ingredients for safety in the European market. So practically, the conclusion is that doses up to 30 milligrams per day in supplements, and if you want to fortify conventional foods and beverages, a dose of 5 milligrams per day is generally recognized as safe for a consumer to use, either as a supplement or a food. Beyond this regulatory review and the safety data, what matters is what we also see in clinical trials that are emerging. Across these trials, we just discussed between, trials of 4 months to 1 year, argathionine supplementation has been reported as well tolerated with no serious adverse effects. Ergothioneine also does not increase plasma triethyl amine oxide, or TMAO. This is a graph coming from our clinical study. We decided to look at plasma TMAO. Plasma TMAO, TMAO is important physiologically, but obviously I think you've talked about it in your channel. Elevated TMAO is often discussed because there is a risk for cardiovascular diseases. So what is the relationship between ergothioneine and TMAO? It's something that the general public does not really think about, but we know of its potential significance, so we decided to study it in our clinical trial. So it's been shown that in certain in vitro studies that ergothioneine as a molecule can be a precursor to to generate TMAO by certain microbial enzymes that metabolizes ergothioneine to TMA in your gut, and then the TMA is oxidized by the liver to TMAO. So we found, as you could see on the graph, there is absolutely no increase in plasma TMAO in response to ergothioneine supplementation, even at the higher dose compared to placebo. So we conclude that if there's any kind of microbial metabolism of ergothioneine in the gut to produce TMA, it's quite minimal. I will say that there's other groups have looked at associations between plasma TMAO and plasma ergothioneine, and they also did not see a link as well. Finally, we saw potential liver benefits. So overall, ergothioneine appears to be quite safe and well tolerated at doses being studied. And in fact, it's considered to have a pretty high safety profile compared to other supplement ingredients. Outside of cognitive health and sleep, there are a lot of other emerging benefits of ergothioneine that are promising, mostly studied in animals. I will say all studied in animals and not yet tested in human clinical trials. This table is also part of the review paper, and I think this is the very last table of the review paper. There is work looking at lifespan, metabolic resilience, including in flies, worms, and rodents. There's studies on gut integrity, looking at things like barrier function and inflammation. There are studies looking at liver health, mainly related to oxidative stress and metabolic injury. And then there are several organ-specific areas that are being studied, including hearing health, eye health, lung health. They're often in the context of oxidative stress exposure. There's also studies looking at cardiovascular outcomes and immune signaling. There's even more studies. On the next slide here, you can see studies spanning related to women's health and preeclampsia, bone, skin, UV radiation, hair follicles, red blood cells, even kidney biology shows up. So it's just a lot. There's so many potential benefits of ergothioneine, it almost makes the molecule sound like snake oil. Like, well, how is ergothioneine doing all these things? It's a very easy answer to this. And the reason why ergothioneine has potential to support all these different health areas is because, hey, our bodies express this transporter in all the cells. Ergothioneine is an antioxidant, plus it has a lot of other, mechanisms such as anti-inflammatory, it could do a lot of things. It could get inside so many different cell types, so many different tissue types, and inside your mitochondria practically in every part of your body. So naturally, there should be some benefit to this molecule, and we are just, as a field, starting to really understand it now. Okay, so I believe this is probably my second to the last slide. We've covered a lot of science so far. Even though this presentation is, I think, reaching up to the hour, I feel like I've just skimmed the surface, really. I am just going through this a breeze. It probably took a long time, but I am really, really skimming the surface of all these mechanisms. I'd even talk about mechanisms or get deeply into the clinical trials or the studies. But okay, we've learned a lot. Let's now talk about dosing. So, if I want to increase my ergothioneine intake, what dose of supplements should I be taking, or how many mushrooms should I be eating? So the foundational dose, which is generally what's thought, is recommended to be 5 milligrams a day of ergothioneine. And that is approximately equivalent to eating one serving of mushrooms. Of course, you probably remember or know that the table indicated that, depends on the mushroom types, the species. You could get 30 milligrams in oyster mushrooms, and you could get 2 milligrams in a serving of button mushrooms. So this 5 milligrams a day dose is really just just like a quick and dirty average of all the mushrooms. So you could just basically think, okay, if I eat a serving of just any mushrooms, I'm gonna get about 5 milligrams a day on average. And that is a great dose to boost your plasma ergothioneine levels over time. And that then is associated with reduction of all these different conditions of aging. Clinically studied doses are, as you've seen, now between 8 to 25 milligrams a day, depending on the clinical study. And there's only four of them. So the 8 milligrams a day, as you remember, is one of the sleep trials. We looked it up to 25 milligrams a day in our healthy subjects. There is the MCI study that looked at 25 milligrams a day 3 times a week. Those are the clinically studied doses. So it depends on what you want to take. You could take between 5 milligrams up to 25 milligrams a day, and that's all commercially available on the market right now. If you want to get ergothioneine from whole foods, if you just love mushrooms and are thinking about increasing your intake, the recommendation is, you could increase your mushroom intake by just one serving a day. I actually, even though I love mushrooms, I find it rather difficult. So, but even increasing your intake by one serving a week can potentially improve health. I didn't show you in this presentation, but in the review paper, the very first set of tables is looking at all the association studies, to my knowledge, between mushroom consumption and health outcomes. And so these recommendations are derived from the association studies and as well as extrapolation from the clinical studies. All right, so we're on the last slide here. If you want to just remember just a few things from this presentation, ergothioneine is stable. It's a long-lived antioxidant molecule with other properties too, found mainly in mushrooms. It's retained in cells thanks to the ergothioneine transporter used to combat oxidative stress and promote healthier aging. There is an inverse relationship between plasma or blood ergothioneine levels and age-related conditions. Doses of 5 milligrams can boost plasma ergothioneine levels, while doses between 5 to 25 milligrams is clinically studied so far to potentially support aspects of health, cognitive, memory, sleep. But of course, we need more clinical studies to really substantiate those doses. Finally, ergothioneine is known to have a pretty favorable safety profile, and we have not seen adverse effects. That concludes my presentation slide today, and I hope you find this nutrient as interesting as I do.
Thanks, Linda. That was great. That was a deep dive of deep dives, and we love deep dives on this channel. It seems like we should all be eating mushrooms, or if you looked at that table, I'm sure that there are going to be people on my channel who are going to say, well, look at the organ meats. Organ meats have a pretty decent amount of ergothioneine,
You're right.
but you'd have to eat 1,000 grams, a kilogram to get milligram amounts. I mean, that's just calorically not possible. And
No.
beans too. So most people aren't eating oyster mushrooms. So then that raises the question of, should we all be eating oyster mushrooms? Because even white button mushrooms in very high doses, even though you'll get some small but significant increase in plasma ergothioneine, should we all be eating, 100 or 200 grams of oyster mushrooms? Because that's the only, and the king bolete, which I don't think are, you can get in the stores. Should we all be
I
eating?
personally have not seen them. The
Yeah.
King Belletti.
So it's either, do you want to supplement, which is fine. I mean, I know you guys that if, for people who don't know, I have an affiliate link now, Life Extension. They sell a product that is linked with you guys. So if you guys want to get the supplement and support Blue California and Dr. Linda May Jean's work, you can do that by using the affiliate link. But for people like me who are into diet, it
Yes.
comes the struggle of, can you even get enough from diet? And do we have to do the supplementation 10 or 25 milligrams per day? So what are your thoughts on that
Yeah,
conundrum of,
that's a great question. It's a practical question. I think I like eating mushrooms. I love putting sliced button mushrooms on my salads, for example. I love a stir fry of, the mushrooms or even the oyster mushrooms and garlic, but I don't cook those things every single day or even every week. So if I actually think about my own diet from a person who loves mushrooms, practically, I probably just eat a whole serving or two of mushrooms a couple times a month. So even a person like me who likes mushrooms, there's a lot of people who don't like mushrooms. We don't just get enough mushrooms. So, I mean, the answer to your question is yes. If you want to get ergothioneine in whole foods, you should intentionally consider branching out beyond the button mushrooms. You've noticed that the button mushrooms are the lowest in terms of all the mushrooms, in terms of the ergothioneine content. So one serving, I believe it's 6 ounces of button mushrooms yields maybe 3 milligrams or so. And the way we eat button mushrooms, I could stir fry the whole thing, but we generally slice it, put it on pizza, just an ounce or so of button mushrooms. That's not going to get you that much ergothioneine. Oyster mushrooms, porcini, if you actually have an Asian grocery store or Whole Foods that sells those, that's great. But, if you're a Whole Foods person, you're listening to this presentation, you're like, oh man, I need to increase my ergothioneine intake. How? But I only want to do Whole Foods. I hate to say you're going to have to increase your mushroom consumption, but it doesn't mean, okay, I have to intentionally eat, a serving every single day. There's studies to show that, hey, if you just boost it by one serving per week, that can potentially support your health.
And
Supplements, that's the pure form. That would be the easiest route. So that's why we are passionate at Blue California to develop this as an ingredient because we recognize, hey, this is something that's low in the diet, and we want people to consider enriching this potentially like the other essential vitamins and foods and providing it as a pure form in capsules. And that's just easier to take.
yeah, so if you had to settle on an optimal amount for daily ergothioneine intake, I mean, granted, it's not recognized as a conditionally essential nutrient, or it may
No,
not be for decades.
nope.
Science is slow on these things. So, from your experience and reading of the literature, would you say is it 10 milligrams per day? Is it just anything more than zero? What would you target as an optimal dietary intake?
Yes, yes, I would target. So it's related to the second to the last slide on dose. I would target to start 5 milligrams a day. I would start target 5 milligrams a day. Right now, we're seeing clinical evidence to suggest more, but those clinical trials are still a short duration. So, ergothioneine, we've learned, accumulates in blood plasma. We don't have any trials to date, except for one looking at 1 year time point. We don't have trials to look at 3 to 5 years, mostly because those are very resource intensive by all factors. And so, just based on the literature, I would say target 5 milligrams a day, whether that's mushrooms or whether that's a supplement. Me personally, I actually have recently switched to 25 milligrams. I wouldn't say daily, but once in a while, once every couple of days, I take 25 milligrams.
Do you notice a difference subjectively or even objectively? So, one of you were on someone's podcast and you mentioned that you were a fitness tracker. So then I thought, oh,
Oh,
have you done the experiment of, I don't know if you're still wearing it, but
I am. I love my Garmin. I love
nice,
I love Garmin.
nice. So then that raises the question of, have you played around with dose of ergothioneine and maybe that impacts, I don't know, so your Garmin, it measures probably HRV, resting heart rate, sleep stages. Do you see a
Yeah,
change?
yeah.
Do
It's
you see?
interesting. So I have not personally intentionally ran a clinical trial on myself.
Mhm.
Although that's something I would definitely do. I've done it in my company. We've done like, okay, take this, let's just do like a blinded, placebo-controlled, like unofficial clinical trial on my friend's colleague's husband, etc. But I will say that I do think, this is biased. Sometimes you don't know what factors play a role, but I do see better sleep. One of my resolutions over time has been improving my sleep. So this year, one key resolution is actually try to get it up to 8 hours and uninterrupted too, which is very hard for me. I don't get 8 hours usually, and I always have sleep disruptions. And I love the Garmin to track sleep. So coincidentally, I will say, I feel like taking the ergothioneine has potentially correlated with improvements in sleep, but I don't know whether it's because I'm being more intentional about, all sorts of other habits. I do feel like that could be a factor. In terms of, actually the main reason why I've upped my dose to 25 milligrams is actually reading these key studies published in Cell Metabolism. There's two papers that look at the mitochondrial health and exercise performance in either mice or rats, and those studies are mind-blowing. And I'm like, hey, that's really interesting. I've been very active since 2 years ago, since I've turned 40. And I'm actually doing my second high rocks in Vegas in 2 months. I did my first one just 2 months ago, and I'm running a half marathon this weekend as an example of fitness. And I have upped my dose because of that, but I will not. I will say that I have not been able to see any tracking. I think it's very hard because you don't know whether any changes that's positive in terms of fitness trackings just result from better conditioning over time,
Hmm.
like, okay, I feel like fitter, but is it ergothioneine or is it because I've just been training for, a couple months longer? There's no way to answer that question, but it's interesting.
But you could get closer to it because if you log the days when you supplement, because you mentioned you're not taking it every day, if you log those days, even as a binary, one or zero, took it today, did not take it today, and then you look at the next day, HRV, resting heart rate, sleep stages, because they're going to line up. And then if you have all of that data, I mean, you could run it 30 days, 60 days. I mean, I've been tracking for 7+ years, so I have 7+ years of data.
Okay.
You can look at correlations in your own data and see if they're actually at least correlated. If they're not correlated, probably not related. But the sleep,
Yeah.
the sleep issue is really important. I mean, you talk about just getting 8 hours and then uninterrupted. I've always had sleep issues where I'm up, I'll wake up once, I can go back to sleep. So to fall asleep, no problem. Sleep onset is great. I'll wake up once, sleep pressure is still high, I can go back to sleep. After that second awakening, which is like clockwork, 5 to 6 hours, I'm up. And then it's
Yeah.
like if I try to fight it and lay in bed, I'm just wasting time. So
Me
I've
too.
chronically, but when you say, you're gonna try to get 8 hours and uninterrupted,
Uninterrupted.
this
Yes.
this to me would be like nirvana of sleep.
No,
So
it's
tiny.
Nirvana. I mean, I do sound like I'm actually claiming that the ergothioneine supplementation is working, but yes. My sleep score is barely over 85 for the Garmin sleep score. And I will say, like in this past week, I've achieved over 90, which is crazy.
With
And
ergothioneine,
with
like
ergothioneine,
unconscious. Yeah. So then that's got so today I had
you should
so
try it.
I eat a lot of mushrooms, but I'll get the 700-gram box of white
Oh,
button mushrooms and then eat that twice a week. So that's an average of
oh,
200. Yeah, I'm a mushroom crusher and I'll eat them
okay.
raw, so
Okay, good for you. That's the
but
best way.
But in looking at your table, and this is where it can get challenging because there are not just one study. I'm going to have to look at the other studies too, where uh, oyster mushrooms, white button mushrooms didn't have as low of a level as you showed on your table, which is why I may have thought I was getting around 10 milligrams a day of
Oh,
ergothioneine. But based on your table, 200 grams of mushrooms per day, I think I'm getting, like you said, just a few milligrams.
just a few milligrams.
So to get closer to that dose, I'm probably going to have to switch to oyster mushrooms and see if that can impact sleep. But I don't know about taste. I don't know if I can eat 700 grams of oyster
No,
mushroom.
that's a lot, especially the oyster mushrooms. They have a very distinct taste.
Hmm.
So,
All right. So, all right, let's dig into like mechanisms or try to dig into mechanisms. So, part of the biggest for me, the biggest fish to attack is why is there an age-related decline? It's probably not intake because almost nobody is eating mushrooms to start with. And you could say, well, maybe people are eating less meat, but there's so little meat, ergothioneine in meat, and even beans. Most people aren't eating beans, so it's, in my opinion, it's probably not a dietary intake story. So,
yes.
what would you think would be the most likely mechanisms, or yeah, underlying mechanisms for why it declines during aging?
Yes, yes. No, it's not, at least in the study, in the one study I showed that looked at ergothioneine declining with aging, those that in that study they actually looked at dietary intake, at least from diaries. And there was no difference. There was no difference between groups. So they concluded it's likely not due to differences in diet. Although it's reasonable, as we get older, we tend to not eat certain foods potentially. But in that particular study, no. There is, that question is still yet to be elucidated, but one potential mechanism is just decreased absorption efficiency, or a lot, as we age, we lose the ability to absorb certain nutrients. So ergothioneine can be one of them. And one reason for that could potentially be reduction of the transporter efficiency in the intestine too. So with oxidative stress, that causes damage to all sorts of proteins, including the transporter protein, as we age. So decrease in transporter efficiency could be one of them. Another potential reason or mechanism could be just increased oxidative stress. You might have increased oxidized ergothioneine. There could be increased metabolism of ergothioneine clearance. Ergothioneine may not stay in the body to do its action as long. But I will say those are all hypotheses and they have not been tested. There has not been a single study to look at young versus old.
In terms of intestinal expression of OCTN1 in the intestine, in
In
terms of
terms
age.
of intestinal expression efficiency or looking at the various pools of ergothioneine versus oxidized ergothioneine.
Yeah, that would probably make the most sense, in addition to obviously, as you mentioned, oxidative stress, because now you have less of the reduced ergothioneine in SH form. Now it's ergothioneine disulfide, and then it looks like you don't have any ergothioneine because it's in the disulfide form. But also as you mentioned, if there's decreased expression of the transporter in the intestine and you can't absorb it, it'll look like it's lower, but then also it'll make its way to the large intestine and then potentially degraded, converted into, as you mentioned, trimethylamine and then oxidized to TMAO. That would make I didn't even consider decreased absorption, but like you said, I haven't seen any published data.
We have not seen published data, in terms of the human fecal matter or in terms of, I will say for the TMAO, like our cohort in our clinical trial was a cohort of 55 to 79 years of age. Now, I will say that we did not look at the data in terms of breaking. Now, talking to you, I probably should go back and look at the data, but there's just no difference. And the error bars the variation is very, very small compared to placebo.
The challenge, though, with ergothioneine being converted into TMAO and then oxidized to TMA or TMA and then TMAO is ergothionase. I may have mentioned this by email, but for people who are watching who may not know,
Yeah.
ergothionase, which is converted by is the enzyme that makes that conversion, and it's actually found in E. coli, which increases in the intestine during aging, which potentially supports it being more prevalent during aging. But it's a pH-dependent enzyme. So it's possible that in your population, even though there's a pretty wide age range of some older people, and even younger people can have relatively high alkaline pH, just it's not a chronological age thing. It depends on gut health. But I wonder if everybody in your study basically had a more acidic, which is quote unquote a healthier gut microbiome, and then you won't see a conversion of ergothioneine into TMA and then TMAO. So do you guys have fecal samples where you can look at
We do
fecal?
not, but it's
Mm.
reasonable because these people are generally healthy. And they're generally healthy subjects. Of course, we don't know whether they have a quote unquote healthier gut microbiome or not, but it's a very interesting question. Potentially there could be, if we were looking at a different cohort of subjects who are diseased or have Crohn's disease, just an example of like the intestinal inflammation, it could be very different in terms of how they metabolize ergothioneine. That's a very good question.
But then you'd have two competing things going on. If people with IBD or other gastrointestinal issues, or even absorption issues, and now more of the ergothioneine
Yeah,
reaches the colon and it's degraded into TMA and TMAO. But then the other side of that is some of that ergothioneine will actually be absorbed through the small intestine. And now you've got higher circulating levels than that you would normally have, reducing some systemic oxidative stress. And then the blood supply goes to the large intestine where it may be able to actually do some good within those. So you have two competing things going
it
on.
is.
Yeah, it's a tricky conundrum. So a challenge there, I think, is plasma levels of ergothioneine aren't commercially available as a blood test. So
No,
is there,
unfortunately.
could that be something that Blue California develops and then offers that as a commercial product, like a finger prick?
I
Finger prick.
know, I know. We don't have the expertise to do that. We're purely making the ingredient and developing the safety. But I will say there are other groups that have talked to me and are considering that. Definitely, ergothioneine should be more easily measured. I mean, you and I probably want to know our ergothioneine. You probably want to know how much ergothioneine you have eating all these mushrooms every day. So I don't know. The only way to do that is to measure in a research laboratory. You could enroll in a clinical trial. We could send our blood to our collaborators, but those methods are all mass spec based and typically very time and resource intensive. It would be
Yeah,
great to have ergothioneine as part of the blood panel.
somebody's got to develop it. I mean, there's a TMAO, right? TMAO, you can get that at Quest, Quest Labs. I mean,
Yeah.
there's got to be a time where we can get ergothioneine. So then the ergothionene's potency as an antioxidant is also really interesting because in terms of concentration, even with 1 micromolar or 1,000 nanomolar, GSH, glutathione, is in millimolar, even, high millimolar range, not 1 millimolar. So we're talking about 1,000-fold difference, glutathione versus ergothioneine. So, and I don't know, maybe I'm getting too deep into the weeds, my biochemistry roots coming out, but is the reaction rate constant for ergothioneine reacting with reactive oxygen species faster than glutathione, which can help make up some of that deficit of you have more glutathione, but it reacts more slowly relative to ergothioneine when ergothioneine sees, oxidative oxidants, inside cells.
Yeah, that's interesting. I will say I do not come from a biochemical background, and I have not looked. I mean, there's probably, I want to say there's maybe a study that maybe has compared ergothioneine reactivity to reactive oxygen species compared to glutathione. I don't know that from the top of my head, but a difference, you're absolutely right. Glutathione is the most abundant antioxidant found in our body. And then ergothioneine, you're taking very small doses and it's just in the nanomolar range. And we're starting to see clinical efficacy at the nanomolar range. What's the difference? The thing is, ergothioneine, even though sometimes it's referred as an antioxidant, antioxidant is just one of its many different properties. And to my understanding, ergothioneine is actually not considered a very strong antioxidant. It's considered a mild or a weak antioxidant in terms
Mm.
of how it scavenges certain reactive oxygen species. Like one example is we commercialize another ingredient that's called taxafolin or dihydroquercetin. People have generally not heard of dihydroquercetin. I think we have heard of quercetin. It's an analog of quercetin. That taxafolin's antioxidant abilities in terms of scavenging free radicals is probably 10 to 50 times greater than ergothioneine based on literature and also in our hands. So I can't imagine, I don't want to claim anything between glutathione and ergothioneine because I don't know that data, but I want to say maybe potentially, but maybe it's just because glutathione is just highly reactive and so you need the whole glutathione redox cycling and recycling in the body, and that maybe affects the way it interacts versus ergothioneine, which is much more stable.
So that brings me back to maybe this is a marker of gut health and not necessarily a marker of oxidative stress, the age-related decline. Because if ergothioneine is lower in blood, and if it's not because it's being oxidized, or it's not because it's being used as an antioxidant, thereby getting consumed, maybe to me that, it's a signal that you've got some, gut dysbiosis where now it's being degraded relative to oxidation. Now, if that's true, so I think there are ways to get around that. So does the Blue California, I haven't looked at their product, your product or what you guys include in the supplement, but is it just ergothioneine, or is it like if you put ergothioneine, so some supplements will have other antioxidants to help keep the stability of
Oh,
your,
sure, sure.
so there are other antioxidants that can help.
No. Oh, yes. Okay, so Blue California, I will clarify for listeners who don't know. I love how you mentioned that in order to support us, listeners can consider buying a life extension as a supplement. So we as a company, we are purely a ingredient developer and we make the ingredient, we make sure it's safe through tests, we substantiate the ingredient through clinical trials and support preclinical work. My responsibility, I was previously an academic scientist before joining Blue California. One of my responsibilities is to make sure, okay, we're selling a high quality ingredient from the safety perspective, and also we're selling an ingredient that works. Of course, that takes a long time. We partner with other brands that sell to consumers. So we don't sell to consumers. I won't be selling to your listeners. I do the science. We do the science and we do the manufacturing. And if any brands out there, and if your listeners includes formulators and brands and product developers from companies like Life Extension, we would partner with, say, Life Extension, and they would include it in their formula. Now they get to choose whether they want to position it as a healthy aging ingredient or a cognitive health ingredient, or add it to a gut health ingredient. Right now, there's very limited literature looking at gut health. I think that whole realm is very interesting. And in fact, that whole table that I showed you with so many, 12 buckets of applications are all very interesting. But yes, we develop an ingredient and then we sell to other brands. How we differentiate is, I mean, there's a lot of ergothioneine supplements out there. Our company's ergothioneine is called Ergo Active. So that's our brand. It's not a brand we sell to consumers, but it's our brand that we differentiate ourselves from other ergothioneine suppliers that maybe don't invest in the science or safety. They're just kind of selling the raw material. We do all the work. We have branded Ergo Active and we sell it to brands. So Life Extension, if you look at the bottle, will say Ergo Active ergothioneine. So you know it's coming from us.
And then what else is in there besides ergothioneine?
So our material is just pure ergothioneine. We sell
Mm.
it as a pure ergothioneine. So other brands, such as the Life Extension, they have a 5 milligram ergothioneine. They combine it with a little bit of vitamin C, and then they have a 25 milligram dose. I can't remember. I think it's supposed to be pure ergothioneine.
So if I understood correctly, you guys are just the ingredient formulation, and then you work with companies like Life Extension who then package it with other stuff to market it and sell it? Or
Yeah,
if you
yeah, we are the ingredient developers. So
ah,
we make the ingredient, we make
aha.
sure it's safe, we test stability, we test it in applications. We literally have this nice, efficacious, safe powder for you. If you ever want to start a brand and you're like, okay, here's something that works, has been tested over years, has the FDA safety. It's a short for it. FDA no objection to grass is a regulatory dossier that we have to submit. That was approved back in 2019. So our ingredient has been tested for many years and has been on the market for many years. So we have this ingredient for you.
So if I was a company like Life Extension and I wanted to go after this, not this hypothesis, but if I wanted to have a direct to consumer product, based on the hypothesis that it's the gut that's the limiting factor in terms of ergothioneine levels in blood, and I wanted to package ergothioneine that you guys, I don't want to say isolate, but synthesize or extract.
Yeah.
And if you put a prebiotic, if you put a inulin or a resistant starch in with ergothioneine, and if they're bound together somehow, like you make so you could have resistant starch bound to all kinds of stuff. That would reach the colon, and then the fiber would be fermented into short chain fatty acids, acidifying the colon, reducing the growth of E. coli and other things that have ergothionease. Maybe you get a bigger spike in blood. So if I was a company, is that something that you guys could formulate, or I'd have to work with another company to develop a product like that?
I love listening to you. I'm sure all your audience loves listening to you. Those are amazing ideas. You already have one product. Yes, we've had gut health companies actually ask us, okay, can we combine the ergothioneine with other ingredients to support, whatever thing they want to market and sell. And we do have a partner with a contract manufacturer that sells that can make a bottle for you, and we would need you as a formulator advisor to say, hey, this is my idea. So I would be giving you the ergothioneine, and that particular company who is responsible for packaging it to consumers and making the capsules, blending, etc. They would source the other ingredients such as probiotics for you. So we are not the ones making the bottles and making the formula. You would have to go through a third party, but we actually have those services for
Cool.
anyone interested, including yourself.
Sounds great. All right, so changing gears, I might be. I don't know. I'm not a supplement guy. I've never been a supplement guy, but if the
Yeah, you
majority,
mentioned that, which is
but if
admirable.
I shouldn't say I'm not a supplement guy. I'm a targeted, a demonstrated need and targeted supplementation. So
Yeah.
as a quick example, like my homocysteine has been stuck 10 micromolar for like 30 or 40 tests. I test a lot. So
Okay.
I'd like to have it lower, and so I'm trying all kinds of things in my diet, trying increase methyl intake. Try anyway. Long story short is Diet really hasn't made a difference. And, I'm looking at correlations. None of that makes a difference.
Oh,
So I'm on supplements trying to change it down.
oh,
But
interesting.
but that's demonstrated need. That's completely the opposite of the majority of the quote unquote anti-aging space, where it's like, I'm going to take 100 supplements. I'm going to take 150.
No, no, you're intentionally,
Yes,
catching what you want to achieve rather than, yeah, taking 100 supplements. I mean, kudos to people who are okay with that. It just scares me a little bit.
for sure. But I may be, if nobody's going to develop a product or the kind of product that I think would be most efficacious, at least mechanistically. If the gut is the major player in degrading ergothioneine, and you could basically optimize the gut, maybe you don't even need to have ergothioneine in the supplement. You could boost plasma levels of ergothioneine just by optimizing gut pH. I mean, I don't know. So I'm open to the idea, but somebody's got to somebody's got to sell something if there's a need for it, right?
Yeah. Where do you test, by the way? And how often do you test?
So fortunately, over the past 10 years, the field of direct to consumer has, for blood testing, has
Yeah.
become a thing. Whereas I'd have to go to my doctor and ask them, basically beg them, where they anyway, that's just a whole nother story. But so yeah, so Quest Lab through ultralabtest.com, they offer it. So I just pick the test that I want. I obviously
Oh,
I pay for it and then go to the lab and pay a $10 lab draw fee, and I can do that as often as I like. So
really? Okay. I've only
yeah,
had experience with the commercial kits like Inside Tracker, and I'm recently trying to think whether I want to do a membership with Function Health. But I never done, picked my test before.
yeah, I'm a different breed though. I prefer to pick it because I know exactly what I'm looking for and what I'm trying to test. But life extension, before I did Quest through ultralabtest.com, I was doing life extension where they sent me the kit and then I brought that to LabCorp. Same process, pay the
Oh,
lab draw fee. The problem there is the blood. So some states, I forgot which state you're in. You're out west though. You're
Southern California.
right. Southern. I don't think California has issues, but Massachusetts, I was there for 15 years, and they have weird blood draw fees or
Oh,
weird blood draw things where for life extension, there are like restrictions. So I'd have to drive into New Hampshire, get the blood drawn there, and then they'd ship it to Florida.
what?
Yeah, it's crazy. So there were a couple of times where my samples didn't get there in time to be measured, quickly enough. So I completely lost samples. So I
Oh
switched
my
over to
gosh.
Quest right down the street. Don't have to worry about it. Didn't have any of these issues. But yeah, there's direct to consumer testing. And the good thing is with Function, and not that I'm anti-Function or any of those places like that, but I think you're basically locked into a panel of tests with
A panel, yes.
yeah, yeah, yeah. Most of that stuff you probably don't need. You could probably condense it down into the basics for a far cheaper cost to get just as much information, if not more. So
Okay, that's good to
yeah.
know.
Yeah,
Yeah.
all right. So going back, wait, so I have more questions, especially on OCTN 1 expression. So the highest levels were expressed in bone marrow by far and fallopian tubes, and then everything
Oh,
else
it's
was
so
kind of
interesting.
lower level. When you look at the published literature, though, I don't think I've seen, or maybe not maybe, but you know better than me on ergothionene's role on stem cells. So stem cells are going to come from bone marrow. That would suggest to
Yes.
me maybe some of its health promoting effects are on optimizing the health of stem cells that are derived from bone. So is there any evidence on that?
As crazy, I feel like this conversation is going to bring up a lot of unanswered questions.
That's okay.
There, unless someone knows the literature better, which is possible because there's so many papers published all the time, there is very limited evidence of I wouldn't say evidence. That sounds like there's just nothing there. There's very limited studies looking at the potential impact on ergothioneine on stem cells. And it's interesting because we have, like you mentioned, ergothioneine transporters express highly in the bone marrow. We know that the transporter is expressed on the hematopoietic stem cells and is also enriched in red blood cells too. But in terms of, okay, does ergothioneine play a role in stem cell differentiation, all these things? I have not seen studies related to that. Fallopian tube you mentioned, there is not a single study looking at that. It might be because, there's only a couple of labs in the world studying ergothioneine. And unfortunately, guys, in the sciences, all our research is dictated by grant funding availability. We would love, I'm sure all the researchers I'm talking to would love funding. And unfortunately, Blue California is a small supplement ingredient company, and it costs a lot of money for development. And we don't have extra money to fund 5 research labs, even though it's my dream to support those research labs. So there's so many unanswered questions. I agree. It's a completely, fascinating potential application.
So there are two things going on there. So if people are able to support Blue California, I know you guys fund clinical studies. Potentially that could be one way where now that question can get addressed, or is that not a possibility?
No, we have some research priorities. If you ask me, hey, can we fund a stem cell study? Our budget is kind of stretched this year
Yeah.
and possibly next year. But we would love anyone who is wealthy investors to
Yeah.
support these researchers or support us, and then we can take turns and support other researchers for sure.
Nice. Hopefully somebody is listening or watching that could contribute like that. The other side of that equation is there may be undergraduate students or even graduate students who are listening or watching right now who maybe this becomes, so science 101 is basically find a hole, find a business opportunity,
Yes.
go after it, and that there are no studies. This could be a whole graduate project or postdoc project in somebody's lab. So addressing it from
Absolutely. And we are happy to partner. Sometimes, I mean, when the budget allows, we do fund studies. For example, 2 years ago, or maybe 3 years ago, we funded a study looking at the effect of taxophilin. It was at the University of Michigan on lupus symptoms because it's not something that we can claim as a supplement company. We have a box that we have to stay in, but we have, a lot of interest. The science really, our company really supports science. And back then we had more abundant research monies. And there was a really amazing study that we published on the effect of taxophilin and lupus in an animal model. We are totally I wouldn't say in the business, but we support researchers. We share information with researchers based on what we've found in our studies and also our expertise working with other researchers. We have high quality material. Can make clinical trial bottles for researchers too. So I am currently collaborating with, I think, actively 6 or 5 different research groups supporting through clinical trial bottle manufacturing and also placebos too, and also just giving some guidance based on what we know on the science. So yeah, we are happy to chat too.
Nice. All right. So telomere length. So telomere length generally didn't interest me much because in terms of what's published, it's a pretty weak biomarker of biological age. There are other composite biomarkers that are more strongly associated with biological age relative to telomere length. But there's a recent preprint that was just published where CD4 T cells that so just as a quick story. So when
Yeah.
antigen presenting cells bind to CD4 T cells, so when you have like an infection, the APCs donate their telomeres to the CD4 cells. And then that rejuvenates the CD4 cells to make them almost stem-like. And then they release telomeres in the blood to
Oh,
rejuvenate systemically. But this is in the context of antigenic stimulation, whether this can be accomplished in people. I mean, it's a preprint. So,
oh,
but when
I would
considering,
love a copy of that preprint. That sounds very interesting.
yeah, I'm going to host the lead author next week on the channel to
Oh,
begin.
okay. We'll
But
stay
when I,
tuned.
yes, but bringing this back to ergothioneine, that ergothioneine can increase telomere length. The study that you showed for that, and I know you guys did it in fibroblasts, or you looked at what was it? Yeah, it was telomere length in fibroblasts. But the study you mentioned earlier was in white blood. I looked up the study; it was in white blood cells, which then makes me think that maybe ergothioneine can do something in that mechanism to rejuvenate white blood cells. But then it raised the question, which is kind of like the fallopian tubes and bone marrow and stem cells. I don't think anybody's looked at the effect of ergothioneine on immune cell, specifically lymphocyte function, not just telomere length. Telomere length is important, but is there an overall improvement in immune cell function during aging? So do you know if there are any studies that have been published on that?
Yeah, I don't know. I don't know if there's any studies that have been published on that. Yeah, those are very interesting, very, very interesting questions.
Yeah. So all right. So for anybody listening, we've got to get studies on bone marrow, especially stem cells, fallopian tubes, or ovarian health, right? I'm guessing there's nothing on ovarian health in with ergothioneine.
No. Yeah, no, I was going to say there are some older studies looking at mostly in animals. I believe in eggs and sperm motility in livestock animals. Very old studies. So there is some in animals, but not anything translatable in humans right now.
Yeah. And then, okay, so then white blood cells, the immune cells, right? So there we have some holes, scientific holes that need to be addressed, right? So, but those would be my interests. Are there studies that you would like to see done for ergothioneine that you think are a top list in terms of important that haven't been done? And then also, are there plans for Blue California, like you mentioned, that you guys have funded studies in the past? Are there plans for you guys to fund or have active clinical studies going on right now that you maybe want to tell us about or that are in the future works?
Yes, I would love to see. I'm still stuck on the two cell metabolism studies on exercise performance. I mean, that is just so interesting. I think it's so applicable to both athletes and just general healthy aging. I would love to see a human trial coming out on that. So that's one. One research group that we have partnered with in terms of preclinical trials, preclinical studies, still animal studies. I just find it really fascinating is hearing health. It's underrated. No people don't generally think about hearing health unless they have a hearing issue. And that is very important for aging, obviously. Everyone probably experiences hearing loss over time. And hearing loss is one of the key drivers for cognitive decline. So it's all interrelated. And so there is a group of professors in the Department of, I think, Biomedical Engineering at the University of Southern Florida who is researching this topic in terms of oxidative stress, effects on inner ear cells, and they're looking at the effects of whether ergothioneine supplementation and can reverse some signs of, just loss, age-related loss. So that's actually really interesting. At first, I was like, oh, it's interesting until I talked to them and they're like, oh, did you know all these things? I'm like, I have never, just like how I'm talking to you. I'm like, okay, that kind of expands my horizons on how I think about some of these applications. Another research group that we're collaborating with is a research group in Stanford University. They published, so basically, they're really interested in helping patients with on dialysis with chronic kidney disease. So this is, a research topic that we as a supplement ingredient company, if anything comes out of it, we can't sell to people because we are restricted to healthy people as a supplement company. It's just a rule. So, there is certain limitations on how we talk about things, but scientifically, we are interested in all sorts of disease states. We see a lot of possibilities for ergothioneine and improving, you know, outcomes in disease subjects. And this particular group, they informed me that when you're on dialysis, you are filtering a lot of nutrients out of the body. And, you're filtering the toxic and you're filtering out beneficial nutrients too. And what they saw in their preliminary study is they filtered ergothioneine out. So these
Mm.
patients are on the very lowest of the low in terms of their ergothioneine levels. So over these clinical trials in healthy subjects, we have a baseline of ergothioneine levels, and that baseline of these healthy individuals is around 900, 800 nanomolar of ergothioneine in their blood plasma. I think they published this in their review paper, but these chronic kidney disease patients on dialysis have very low ergothioneine levels. I think their direction is so interesting because you alluded to ergothioneine not being classified as an essential, it's not an essential vitamin or nutrient, and it's not classified as such. It's potentially conditional. And one reason is because we do not have a known ergothioneine deficiency disease right now. everyone, even if they don't eat mushrooms, can get ergothioneine somewhere in their diet. There's no deficiency known. And the hypothesis is that if you have low levels of ergothioneine, you're not going to manifest in like scurvy in a couple months or goiter, as in, if you have a vitamin C or a D deficiency, what you manifest is cardiovascular disease or dementia. I mean, it's going to take decades to figure that out. And so it's really interesting that, potentially in the chronic kidney disease model, that can be one potential model, even though you have so many factors, there are obviously issues with their kidneys. Um, it could be a model for a deficiency syndrome. And so this particular group wants to ask the obvious question, does replenishing ergothioneine to this particular, you know, patients, can it improve just their quality of life, how they feel, metrics like sleep, just, how do they act every single day? So that's another partnership we have, which is very interesting. There's just several. I mean, every single thing on that table, gut health, like you said, immune function, all these applications of ergothioneine, I would love to have. I think they're all equally important. Some get more spotlight than others, but they're all very interesting for how we age.
The CKD study is fascinating, not just from the point of view of dialysis filtering it out, but there is a segment of the longevity community that are doing things like plasmapheresis and plasma
You're
dilution.
right.
And
Yes.
and if you
Yes.
look at the published studies, like
So
sure,
right.
maybe it can reduce, and I say maybe because what works in published studies, you'd actually have to measure it to see if that worked in you to remove the things you want to remove, whether it's
Yeah.
microplastics or heavy metals, whatever it may be. But it also dramatically depletes all kinds of good stuff. Like you mentioned, the big things, albumin,
Yes.
HDL. Granted, some things like inflammation will go down, but as you mentioned, if you're taking out ergothioneine and you're not replenishing it, the long-term effects of this may be potentially bad. In terms of the deficiency syndrome, it
You're
got
so
me
right.
thinking, and granted, this probably won't be recognized as a disease for a very long time, but aging. I mean, you could argue,
Yeah. Yeah. Aging is a
and along those lines, I think I mentioned this in email, but Richard Miller at the ITP, the Interventions Testing Program, they did a metabolomic analysis of their long-lived animal models in response to supplement or drug interventions, right? Because they basically give supplements or drugs and they see if the animals live longer in very large, I mean, it's like the gold standard of longevity research in mice. And ergothioneine levels, if you look at plasma ergothioneine levels they did 5 interventions, plasma metabolomics. I think it was like rapamycin, calorie restriction, and then a few others. Ergothioneine was consistently higher in the animal models of
oh,
longevity relative to controls at a very young age, only at like 12 months old, which is
oh wow.
early for a mouse. So that would suggest that maybe the lifespan extending effect that comes with these longevity promoting interventions. Granted, it's just an association, but
Yeah.
ergothioneine being higher in these lifespan extending interventions suggests that it may have an important role. So it will take decades for that to be recognized if ergothioneine is essential to slowing, aging process in terms of
Yes.
getting it recognized as conditionally as essential. So anyway, that was great, Linda. I appreciate it. You did a great job, and I'm looking forward to having you on the channel again at some point. And
Oh, I would love to. This is a very invigorating conversation. Thanks for
oh,
having me on the channel and also talking about ergothioneine. I think it's probably the first time you talked about ergothioneine on this channel too. Oh man, I think people should know about this nutrient and follow the science. It's just, I think we're going to have really good science coming out in the next 5 to 7 years. Hopefully
nice.
with more research funding too.
Yeah, sounds great. All right, thanks, Linda, and have a great day.
Okay, thank you.